Students, we are given this question. Find the differential equation of the family of circles passing through the point a, 0 and negative a, 0. Now, if we are to have the axis x and y to be like this, and the point a of 0 is something over there and negative a of 0 is something over here. Now, we are expected to find the differential equation for the family of circles that passes through the point. So circles are actually passing through this point. It's a rough sketch, okay? Now naturally the center of the circle will be located on the y-axis. So let us write that down. So this is the solution answer. Since the circle passes through a, 0 and negative a, 0, the center of the circle should lie on the y-axis. Okay, so let that point be, let that center be located at 0, b. Now this would mean the radius of the circle, what it would be. Say if I have 0, b center and a, 0 to be a point on the circle, then the radius is going to be 0, negative a squared positive b negative 0 squared, the whole square root, right? So this is going to be equal to root of a squared positive b squared. This is going to be the radius, right? Now the equation of the circle, so therefore the equation of the circle is the center is 0, b and the circle passes through a, 0. So I can rewrite the equation to be as x negative h the whole squared positive y negative k the whole squared is equal to r squared. This is the one of the forms of the circle. Now since the center, where h, k is the center, okay, the center of the circle is located as h, k. So this would mean the system x negative h is going to be x negative 0 squared positive y negative k. My k is going to be b, so that has to be raised to the power 2. My r is root of a squared positive b squared, and you have to square that, so using the equation of the circle. So this can be rewritten as x squared positive y negative b raised to the power 2 is equal to a squared positive b squared. Now we will be differentiating both sides with respect to x. So when we do that, we would get the following. Differential of x squared is going to be 2x positive. Differential of y negative b raised to the power 2 is going to be 2 times of y negative b, okay, times differential of y is going to be dy over dx is equal to, now a squared and b squared, both of them are constant, so this is going to be giving us 0. Now what I'm going to do is I'm going to be moving 2x to the other side. So that would give me 2 times of y negative b times dy over dx is equal to negative 2x. I can cancel the 2 out on both the sides. So that is going to be y negative b times dy over dx is equal to negative x. Now the idea is to eliminate b. In other words, to have a representation for b. Now this is one of the representation. So from here I can rewrite y negative b to be as negative x divided by dy over dx. So this is one representation. Also from here you can rewrite b to be as y positive x divided by dy over dx is equal to b. So this is also one of the representation that you can have. Now, since I have two representation, what I'm going to do is, let me name this as 1. I'm going to substitute the value of b there, and from there I'm going to perform some simplification so that I'm able to obtain the differential equations. So therefore, using the values of b and y negative b, therefore 1 becomes, this is going to be x squared positive y negative b. I'm going to substitute this negative x divided by dy over dx. That has to be raised to the power 2, which is equal to a squared positive. In the place of b, I'm going to substitute this. It's going to be y positive x divided by dy over dx, and that has to be raised to the power 2. This is what I've got. Now, if I were to square this, this is going to be x squared positive x squared divided by dy over dx raised to the power 2 is equal to a squared positive. Now, this can be flipped and rewritten as y positive. I can write this as, well, instead of flipping it, what I will do, I will take the LCM as dy over dx. Okay, so if I were to take the LCM as dy over dx, this would be y times dy divided by dx positive x. So within the square. Now this can be rewritten as, with the LCM, if I were to take the LCM as dy over dx, the whole squared, then I would get x squared times dy over dx raised to the power 2 positive x squared, this is one term, and is equal to, now I can rewrite this as a squared positive y times dy over dx positive x, this as one term, divided by dy over dx raised to the power 2. Now taking the LCM for the right side, that would give me dy over dx raised to the power 2, and this can be rewritten as a squared times dy over dx raised to the power 2 positive y times dy over dx positive x raised to the power 2. On the left you got x squared times dy over dx raised to the power 2 positive x squared divided by dy over dx raised to the power 2. Now dy over dx raised to the power 2 can be cancelled on both the sides, so that is going to be giving me x squared dy over dx raised to the power 2 positive x squared is equal to a squared times dy over dx raised to the power 2 positive x positive y times dy over dx raised to the power 2. So this is what I am getting. Now what I can do, I can club all the dy over dx on one side. So I rewrite this as x squared times dy over dx whole squared. I bring this negative a squared times dy over dx whole squared. Now this term, I'm going to simplify that within a few minutes, so just hold on. So I place this x squared on the right side. I just have x positive y dy over dx whole squared. So what have I done? I have brought this to the left and I have rewritten it. Now I'm going to expand this right side. That will give me x squared positive 2 times xy dy over dx positive dy over dx whole squared along with y squared. On the left it's going to be x squared dy over dx raised to the power 2 negative a squared dy over dx raised to the power 2 positive x squared. Now clearly the x squared can be cancelled. I can move these terms to the left, so I'm going to move this term, so that is going to be x squared times dy over dx raised to the power 2 negative a squared dy over dx raised to the power 2 negative y squared times dy over dx raised to the power 2 is equal to 2xy dy over dx. So this is what I've got. Now I can take dy over dx as a common factor. Now if I take it as a common factor, I would get x squared negative a squared negative y squared times dy over dx raised to the power 2 is equal to 2xy times dy over dx. Okay, now I can cancel dy over dx out, so that would give me x squared negative a squared negative y squared times dy over dx is equal to 2 times xy. Now I can move this to the left, so therefore this is going to be x squared negative y squared negative a squared, club the variables together first, times dy over dx, and you can move this, so that's going to be negative 2 times xy is equal to 0. Now this is the required differential equation that we need.